So picture this. You have an absolute mountain of data, but only a tiny, tiny fraction of it is actually labeled and ready to use. What do you do? Well, today we're going to dive into a really clever solution in machine learning that finds a sweet spot right in the middle of two classic concepts, and it helps you make the most of every last bit of data you've got. All right, so here's the game plan. First, we'll kick things off by looking at the learning spectrum to set the stage. Then, we'll get into a super common data problem that, trust me, trips up a ton of projects. After that, we'll uncover the elegant solution, break down exactly how it works with a cool technique called pseudo-labeling, and then we'll wrap up with the good stuff, the big payoff. Okay, so to really get what makes this middle ground approach so special, we've got to start with the basics, right? Let's look at the two big extremes in machine learning. On one end of the spectrum, you've got supervised learning. This is the classic stuff. It's where you feed a model data that's already been neatly labeled by people. Thousands of pictures all tagged cat or dog. Then, way over on the other end, you've got unsupervised learning. This is totally different. Here, you just dump a whole bunch of unlabeled data on the model and basically say, okay, go figure it out. Find some patterns for me. These are the two opposite poles of the machine learning world. So, you've got these two clean extremes. But, as we all know, the real world is a lot messier. And that's where we run into a really, really common and frustrating data problem. I mean, think about it. It'd be amazing to have mountains of perfectly labeled data for every single project, wouldn't it? But what's the reality? When you actually get your hands on a dataset, what does it really look like? Is it all perfect and clean? Yeah, this is the reality check right here. The truth is, it's almost never balanced. You usually have this tiny, precious little pile of data that you've painstakingly labeled by hand, and then there's this absolute mountain of raw, unlabeled data just sitting there. And that's the big dilemma, isn't it? Going through and labeling that entire mountain by hand, it's just not practical. It's too slow, too expensive. But at the same time, we know more data almost always leads to a smarter model. So what do you do? Just throwing away all that unlabeled information feels like such a massive waste. So what's the move? Is there a way out of this mess? You bet. This is where a super elegant solution comes into play, one that finds that perfect middle ground and, honestly, gets the best of both worlds. It's called semi-supervised learning. And the name pretty much says it all, right? It's not fully supervised, not fully unsupervised. It's semi. It's this awesome hybrid approach that doesn't force you to choose. Instead, it cleverly uses both. That small bit of labeled data you have and that huge pile of unlabeled data. The best part? Nothing goes to waste. Okay, so how do we actually do this? Well, there are a few methods, but one of the most powerful and, frankly, coolest ones is called pseudo-labeling. It's a really clever process where the model basically learns to teach itself. And that name, pseudo-labeling, it gives you a big hint about how it all works. All right, let's pop the hood and see how this actually works. How on earth does a model become its own teacher? It sounds complicated, but the process is actually super intuitive once you see it laid out. Okay, so check this out. Step 1, you take that small, high-quality set of human-labeled data you have, and you train a basic model on it. Standard stuff. Now for step 2, you take that new model and you unleash it on that giant mountain of unlabeled data. You just have it make predictions on everything. And here's where the magic happens. Step 3, you look at all those predictions and you cherry pick the ones the model is most confident about. You take those confident predictions and treat them like they're real labels. We call them pseudo-labels because, they're not from a human, but they're our best guess. Step 4, you combine your original, trusted labeled data with this massive new set of pseudo-labeled data. And finally, step 5, you retrain the model on this brand new, much, much bigger data set. It's now learning from way more examples than it ever could have before. So that's the whole trick. Pretty clever, huh? But what does this all mean in the real world? What's the big payoff for doing all this? Well, let me tell you, it's an absolute game changer. First off, the advantages are just massive. You get to train your models on way, way bigger data sets than you ever could before, which helps you create models that are way more accurate and robust. Plus, think about it. You're saving just countless hours of boring, expensive human labor. We're talking huge cost savings. And honestly, this is the big one for me. It makes some projects possible that would have been total non-starters before. The ones where labeling the entire data set would just cost way too much money. And that really leaves us with a pretty cool idea to chew on. This whole process is really just about giving a model a little bit of help, a little head start, and then letting it go out and teach itself using all the data that's out there in the world. It kind of makes you wonder, right? When a model can teach itself, what can't it learn?